Okay, so the reason that we have to learn about imaginary numbers in algebra is just because it solves the problem of when you have a parabola that looks like it doesn't cross the y-axis or the x-axis. It really does. Because the real axis in three-dimensional world, which is the world we live in, goes like we have our x, we have our y, and then we have our z. And the parabola that looks like it doesn't cross the y-axis or the x-axis, it really crosses that z-axis. Crosses in three-dimensional there. Okay, so you can kind of see this chart. So it's just comparing negative numbers and imaginary numbers or complex numbers. Negative numbers were invented from the video to answer questions like 3 minus 4. Complex numbers were invented to answer questions like the square root of -1. And they're kind of weird, right? But negative numbers mean opposites. Complex numbers talk about rotation. So there's a lot of applications with where this comes up. It actually comes up a lot if you're an electrician. They measure conductivity of circuits with negative numbers. So it's kind of interesting. But yeah, coordinates. If we talk about the coordinates, we would plot the x and the y-axis, and then that complex number talks about a rotation about the origin. So it's kind of cool. And we measure with the Pythagorean theorem. All right, so on 4.6, I think we just keep it simple. The imaginary unit I. We are going to use I to mean the square root of -1. Okay? That is going to help us actually find the square root of negative numbers. Nur, put your head up and take notes, please. Nur, hello. Head up and take notes, please. We're not sleeping. This also means that I squared is the same as -1. So if we wanted to get rid of the square root, we square both sides. Okay? So either one of those are definitions. That's what it means. Okay, so the way it works, if we have a positive real number, so for example, if we have the square root of -25, you can kind of view it any number of ways, okay? If we view it like we've been, totally gonna sneeze. Sorry, video people. If we view it like our simplest radical form we've been doing, then we can change that square root of -25 into the square root of -1 times 25. And then we're going to take the square root of each part. And then that square root of -1, we know what that means because it's right up here. That's I. And then the square root of 25, what's that? What's the square root of 25? Nur, square root of 25? Oh, he's busting out a calculator. I'm always okay with that. Because who keeps all those things in their head? I don't. I mean, I do. I'm not going to lie. But Peyton, you got him? Square root of 25? 5. Yep, that's okay. That's all right. I sprung it on him. Hi, Keelani. We're doing 4.6. So that's 5. And see how I stuck it in front of the I? Thank you. I stuck it in front of the I like that because it's a variable, right? Anytime you have a number with a variable, the number goes first. Okay, now also, if I wanted to work backwards, if I was taking the square root or the square of something I, so let's say I was taking the, I don't know, let's work backwards. Let's say I'm going to take the square of 5i, okay? So then that means I would have, yeah, there it is. I would distribute that squared. So I'd have 5 squared times I squared. 5 squared is what? What's 5 squared? 25, right? 5 times 5. And then I squared is up here. I squared is the same as -1. So I would just replace that with a -1. So this turns into -25. So we just got to get in our head that that -1, that actually equals I squared, or the square root of -1 actually equals I. We're just going to practice kind of interchanging them. I squared is the imaginary part. That's what we're dealing with. I squared turns into what number? Sonny, what does it say up there? I squared turns into... What does I squared turn into? -1. Okay, so we can find the square root of each number using that I and our perfect squares. So all of those things we did in section 4.1, it's back. Yay! So we can simplify all those squareds that way. Okay, get your note packet out. Chapter 4. You don't have one? Okay, look on the side there. Find one that says chapter 4. Does that say chapter 4? Yeah, that works. That one's for, it says honors, but it's the same material. It's good. Okay, so square root of -25, we're going to break down. We kind of just did it, right? We can take that negative and turn that negative into -1. And then 25 is a perfect square. So then we go through the square root of -1 times 25 is the same as the square root of -1 times the square root of 25. Square root of -1, what does that equal now, guys? I, that turns into an I. Square root of 25, we already said it, it's 5. And then I put my number first, variable second. Now 72 is not a perfect square, so we got to simplify it using that list. Remember that? Our perfect square list, 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. Okay, so, and feel free to come grab a calculator if you need it. But first thing I can do, see that square root of -72? I'm going to pull that negative out, and I'm going to turn that into a -1. -1 times 72. Now I just got to break up the 72. What's the biggest perfect square you can divide 72 by in that list? What's the biggest number that'll divide by? Come grab a calculator. If you don't know it, come get it. What do you guys think? Biggest perfect square. So 72 divided by 4, divided by 9. Might even get higher. Come get a calculator, you guys. Okay, come on up, please. Come grab a calculator. Thank you. She didn't even move. She's like, whatever. See, I know. Bring me one. I'm just kidding. I'm teasing. Okay, what is the biggest number in that list that 72 will divide by? I'll tell you, 9 works. 72 divided by 9 is 8, but there's a bigger one. So try to find a bigger one. I saw the look on Peyton's face. She knows it. She knows it. Emerson, you got it? 36? Yeah, very good. 36, what do you get when you divide it? Was it 2 or something? It was 2? Okay. Very cool. See, so it's -1. So now that 72, I'm going to split that into 36 times 2. And then taking the square root of all those things is the same as the square root of -1 times the square root of 36 times the square root of 2. Square root of -1, I know what that is now. What is that? What is it? I. Yep, square root of -1 is I. What's the square root of 36? Peyton, what is it? 6. And then that square root of 2, we just leave it. And then we just flip-flop it so the numbers first, variables second. Okay? All right, let's do number C. Kind of works the same way. If there's a number already there, whatever you bring out, you're just going to multiply by it. That's it. So -5, we leave that alone. -9, 9 is a perfect square. It's on that list. So all I got to do is take that -1 out of there. Okay, so -5 is still there. We've got the square root of -1, square root of 9. Okay, what's the square root of -1? That's I. Square root of 9? What's the square root of 9? 3. And then those two numbers, we're going to multiply them. -5 times 3 is -15. So it's the same stuff you already did. We're just adding a -1 in there. That's it. Plus, you guys are awesome. You didn't argue with me about the purpose of imaginary numbers like my other classes did. Just kidding. Okay. Any questions on that? So it just turns into a -1, and now from here on out, you guys, here's what's awesome. You treat it like a variable. You combine like terms. That's it. Easy peasy lemon squeezy. So this is a great homework, and I take back my worries about your homework. I did see quite a few of you just already turned in the homework before the weekend, so good job. Nice job, friends. Okay? If you go quick and come back, and make sure your computer's closed so you listen when you come back, okay? So go ahead. Go quick. All right, let's go to the next page. Again. Okay, so now we have a complex number, okay? Complex number is, if you kind of look at it, we have real numbers. You guys did this before where, remember, real numbers can be irrational. They can also be rational. And then you have integers. And then you have whole numbers. And then you have natural numbers. Okay? So now what we're doing is we're adding a new plane of numbers. We have imaginary numbers, which are actually complex numbers. Okay? They are made up of a real part and an imaginary part. So the way it works, a complex number has a plus bi. It's got a real part or an imaginary part. If your b equals 0, so if b is 0, like here, then you have a real number. If a equals 0, then you have what's called a pure imaginary number. Okay? And if you have both of them, then that's called a complex number. Okay, can you close your computer when you're done? Thank you, my dear. So, the complex numbers we're going to treat, so that involves the real, like if we're plotting that on the axis, that involves like plotting where it is, which is the real number part, and then that imaginary part, remember, is that rotation. You guys won't have to worry about plotting it. We could do that, but no, not part of the lesson. Okay, next part. To see it, everybody can see it, and Leilani and whoever just kind of came back, you are so okay. So all that we have to do in this part, find the values of x and y that satisfy the equation. So all we're going to do is put the real parts together and then the imaginary parts together. That's it. So remember, a plus bi, this is the real part. This is the imaginary. So we have 2x minus 7i equals 10 plus yi. So we're going to set the real part equal to the real part. 2x equals 10. And then we're going to set the imaginary part equal to the imaginary part. Okay? So now, here's what's weird. We know how to solve it. It looks kind of weird with the I next to it, right? But remember, it just stands in place for a number. That's it. So don't overthink it. So we want to get the y by itself. So we're going to do the opposite of multiplying by I. What's the opposite of multiplying by I? Dividing by I. Yep. So the i's, see how the i's are just going to cancel because you have negative 7i divided by I. When you divide by the same thing, it just cancels itself out because the same over the same is 1. So we get negative 7 equals y. And then what do I do on this side to solve for x? What do I do? Say it again. Divide by the 2. That's right. So we get x is equal to 5. So real part equal to the real part, imaginary part equal to the imaginary part. That's all. Now down here, easy peasy lemon squeezy. We just treat it like adding polynomials. That's it. We're going to combine like terms. So that means I'm going to combine the 8 and the 5. And then I'm going to combine the negative I and the 4i. So what's 8 plus 5? 13. What do you guys think? Negative, remember that's a 1i. Even if I don't see the 1 in front of it, I could add it if I wanted to. What's a negative 1i plus 4i? 3i, yeah. And that's it. That's what you put. You can't combine that and say 16i because that's the real part and the imaginary part. We got to keep them separate. Okay, now this side, I got to do something first. You see how there's a negative, a minus, a subtraction sign? When that happens, we want to subtract the whole thing. So we got to distribute that minus. So we're going to go minus 3, minus 6i. And then I always write it out, what it looks like after you do that. Because it's just helpful to see it. It really is. All right, now we're going to combine the 7 and the negative 3 and the negative 6i and the positive 6i. What is 7 minus 3? 4. What's going to happen with the 6i's? They're canceling, right? Because it's a negative 6i and a positive 6i. That just gives you 0. So our answer is 4. Easy, right? You just treat it like a variable. That's it. However, you're going to want to have your notes next to you, and you're going to want to make sure you do the practice. I want it in my front. Okay. Oh, same deal. We're going to combine like terms. So 9 and negative 6, and then negative I and 7i. I did not have to distribute a negative because I'm adding. So what do you guys get for this one when you do it? Yep, that's right. 3, 9, and negative 6 is 3, plus negative I plus 7i is 6i. Good job. All right, number 2, what do I have to do there first? Yeah, I got to change it. Change the signs. You're right. I'm going to share that minus. So we get negative 8, positive 2i. Then we've got some like terms to add, negative 3 and negative 8, and 7i and 2i. Okay, what's 3 and negative 8? Negative 5, good job. 7i and 2i? 9i. And notice how we always put our real number first. It's always real plus imaginary. Okay? Next one. Alrighty. And so here, okay, when you multiply, it works the same way as a variable. We just have to do one extra thing. You know the I squared? Do you guys remember what does I squared equal? Negative 1. Yeah, we got to keep that in mind. So we might have to substitute it in. Okay, when we have a number on the outside, parentheses, what property do we use here? Starts with a D. Distributive, that's right. We're going to multiply. And it works just like a variable. 4i times negative 6, I multiply the numbers together. I get negative 24i plus 4i times I. What do you guys think I times I is? I squared, that's right. Good job. 4i squared. See the I squared? We're just going to do that extra little part where we change I squared to negative 1. Just because we know that's the definition. Okay, so now we can do the math. So we get negative 4, and then I just got to be careful. I got to move that negative 4 in the front just so I write it in the right format. Because it's always got to be real plus imaginary. Okay? Questions on that? Or it might be that it's just kind of new and it's going to help you to practice. What method do you think we're going to use to multiply number 2? Say it again. We could use FOIL. What's the other one that we kind of like better? Box method. Yeah, and you might not like box method. You might like the FOILer, and that's okay too. But I like box because it clearly lays out all of your terms. And I got to use my pretty color. Okay, so we can line it up. Remember, it doesn't matter what side you pick. So the first one, I'll just put on the top, 9 and negative 2i. Second one, I put on the side, negative 4 and 7i. Okay, what's 9 times negative 4? Negative 36. You should not feel bad if you ever have to grab a calculator to do stuff that you know you kind of already knew. Your brain is focused on learning a new concept, so sometimes it helps to reinforce that multiplication. So negative 4 times negative 2i Remember, you're just multiplying the numbers. What's negative 4 times negative 2, Emerson? 8i. Thanks, Sonny. 7i times 9. What's 7 times 9? What's 7 times 9? 63. Thank you. 63i. And what's 7i times negative 2i? So the 14. Thank you. Negative 14. Although Sunny's right. And then we've got the I squared because once we do our switcheroo, it's going to change that negative 14. Yep, it's going to be positive because we know I squared is the same as negative 1. So here's what we're going to do. We're going to add diagonally because those are both i's. So we can combine those like terms. We can go 63 plus 8. What's 63 plus 8, guys? 70, what is it? 71. Yeah, that sounds about right. So we got 71i. And then this guy, we know I squared is the same as negative 1. So negative 14 times negative 1 is positive 14. So then we end up having to add these guys, positive 14 and negative 36. Negative 22? Yep, very good. So our answer would be negative 22 plus 71i. So you just end up doing a little bit more combining like terms with that. Okay? Does that make sense? We've got one more part to do. And it's pretty similar. So make sure you have your notes next to you so you just remember the new, kind of the new parts of it. I gotta update my board over there. Man, I didn't wear my imaginary number shirt, you guys. I wore my graphing shirt, but I need to up my math teacher wardrobe. I just do. All right, because last part, complex conjugates. Conjugates are opposites of each other, okay? So if we have some kind of a imaginary number, to make the conjugate, all we do is we change that plus to a minus. That's it. And then it's vice versa. If we have a number that looks like this, the conjugate of that would be changing that minus to a positive. So you just flip that sign. And the reason we do that is because it helps stuff cancel. So, hi Elise. You actually have to go to, you know what, Nadia? I think they lied to me about if Elise was here. I tell you. Oh, did you finish your forward test? You did. Okay, never mind. Never mind. They didn't lie to me. I wanted to make sure I didn't mark you absent. And I didn't. They told me you were here. Pull out 4.6, and we're just doing the very last example, and then we're done. So you'll have a part of it. Yay! Okay, so we want to see what happens when we, and I did turn this lesson into a video, so I'll post the video so you can go back in and take notes. So we have 5 plus 2i, right? We want to multiply by its conjugate. So if we have 5 plus 2i, what would the conjugate of that be, guys? I'm like looking at Lynx, like, come on, Lynx, I know you know. Oh, I appreciate that. That's good. Who else should I bug? Ner. I'm gonna pick on Ner. Yes. Which part of that is going to change to make it a conjugate, Ner? The minus, you're right. You're so right. It's going to change to a minus. So now all we got to do is multiply that together. And what's our method to use? What's our method when we have two polynomials? Like, it's just like the last one we did. Box method, yep. So let's see what happens when we box method this guy. So we've got 5 and a positive 2i, and then 5 and a negative 2i. I can get you another packet. Okay, I can get you. Okay, I'll take it. It's all good. What's 5 times 5? 25. You can just put it on my desk, my friend. I'll enter it right away. 5 times negative 2i. What's 5 times negative 2? Negative 10i. What about this one? 5i times 2i. What would that be, Jojo? What's 5 times 2? It's all good. I told you. Don't be shy. Don't be ashamed.
What is
10. 10i. Good job. And then 2i times negative 2i, Sonny. What's 2 times negative 2?
2 times -2?
That would be adding. Multiply. 2 times 2? 4.
4i to the square.
Yep, that's right. And it'd be a negative 4i squared. Very good. Okay, now we got to do our combining. 10i and negative 10i. What's going to happen there? It cancels. And then we got to do our replacement. I squared is the same as what, Yesel? What did we say? Negative 1. Negative 1, that's right. So we're going to replace I squared with negative 1, so that's going to turn it positive. And then all I got to do is combine the 25 and that positive 4. What's 25 plus 4? 29. So when we multiply by a conjugate, it makes the i's cancel out. Kind of cool. Hi, Leilani. Okay, last part. We have 4 minus 7i. What would the conjugate for 4 minus 7i be? Sienna, wake up. Wake up, wake up. Come back to the living. What would the conjugate be? What's going to change on that? What do you think? Will, what do you think? If we have 4 minus 7i, what's the conjugate?
4 plus 7i.
Yes, sir. That's right. And we're going to work it the same way. We're going to box method that puppy. Okay. 4 times 4? What's that? 16, thank you. 4 times 7i?
28i.
Nice. Negative 7i times 4? And then negative 7i times 7i. Nice. And then I squared, what's that going to turn into? That's our definition, Sonny, and I'm going to show you. What we'll do is we're going to replace I squared with that negative 1. So what's going to happen to that, Sonny? Negative 49 times negative 1? Positive 49, that's right. And then looking diagonally, we've got negative 28i and 28i. What's going to happen there? They're dead. Cancel out. So now we just got to combine 16 and 49. And please don't make me do math in my head this early, friends. What's 16 plus 49? 65? You guys agree? 65? 65. Sounds right. Looks right. So that is our answer. So when we multiply by a conjugate, it makes the i's cancel.